Magis Day students, welcome to another day of learning. So for this video, you will learn to divide a polynomial with another polynomial using synthetic division. Alright, so in dividing polynomials, I must say that this synthetic division is a blessing, for this is way simpler than long division. But remember that this method is not applicable all the time, as it only works when the divisor is in the form of x minus k, where k is any constant number and x has an exponent of 1. So before you do synthetic division, before you use synthetic division, you have to check the divisor and make sure that these two conditions are there. Okay, these two conditions are satisfied. Okay, so let's have our first example. X cubed plus 6x squared plus 8x minus 2 divided by x plus 3. So this is basically a polynomial divided by a binomial. Now, notice class that in the divisor, this is what I was telling you, you have to check the divisor. And notice that the divisor is in the form of x minus k. Okay, although it's not minus here, it's plus, but it doesn't matter. For as long as you have the variable x, okay, as the first term of the divisor, and followed by any constant number. Okay, and make sure that your variable x has an exponent of 1. So in this case, we can apply synthetic division. So the first thing that we need to do is to draw this how do you call this one, this symbol. So we have here it looks like L. Yes, so this is what we call as this is the symbol that we will be using for synthetic division. Okay, so what we do, we set the divisor, we equate the divisor to 0 and solve. Okay, so the divisor is x plus 3. So again, we equate it to 0. So x plus 3 equals 0. So that will give us x equals negative 3. So we put the negative 3 here. No? All right. And then for the next part, we have to list all the coefficients numbers in front of each term in the polynomial and the constant along the top. Okay, if a term is missing, we have to put a 0. Okay, we have to fill in the missing terms. Okay, so we have here for x cubed, our coefficient is 1. For 6x squared, obviously our coefficient is 6. And for 8x, our coefficient is 8. And we copy negative 2. Okay? So that's the third step. Okay, next, we bring first number down below the line. So we bring down 1, and then we multiply these and put answers above line in next column. So we multiply the 1 with negative 3. Negative 3 outside. Okay, so what is 1 times negative 3? So that's basically negative 3. And then right after that, we add 6 and negative 3, and that's positive 3. So we go back. We multiply the the 3 below with the negative 3 on the side. So that's going to be negative 9. And then we add again. So we'll get negative 1. And then after that, we multiply again the negative 1 with the negative 3 on the side. So that will give us positive 3. Okay, and then we add these two numbers that are aligned. No? So we have positive 1. Okay. Next, so since we have here a number, no, greater than, how do you call this one? Not less, not equal to 0. Yes, because this could be negative. The remainder could also be negative. So since we have here a number not equal to 0 as our last, um, how do you call this one? Coefficient, or shall I say last number, no, in performing synthetic division. That means to say that our remainder for this example is 1. Yes. Okay, but what about the answer? We're not done yet. Okay, we still have to um arrange our quotient for this polynomial division. Okay, now put variables back in. So remember, 1x was divided out in process. So first number is 1 less power than the original problem. So what's the highest exponent in the dividend? So it's 3, right? So the highest exponent in the dividend is 3. So what is 3 minus 1? That's 2. So meaning to say, the highest exponent of your quotient must be 2. Why? Because it has to be 1 less power than the dividend. Your quotient must be 1 less power than the than the dividend. Okay, so again, the highest power in the dividend is to the power of 3. It's 3. So you subtract it with 1. 3 minus 1 is 2. So that means to say the highest exponent of your quotient must be 2. Okay, so you put the variables back and we will use these numbers below as the coefficients. So we have 1x squared plus 3x minus 1, and then we have the remainder 1. I repeat, the highest exponent for the quotient must be 2. So we have to put x squared beside 1. And then what comes after x squared? So it's a term, it's a variable with an exponent of 1. Okay, so x squared, then we have 3x, and then we have negative 1, and we also have the remainder, which is also 1. Okay. So how do we write our final answer? So it's going to be x squared plus 3x minus 1 plus, remember how to write the remainder. So you put the 1 divided by the divisor, which is x plus 3. So as you can see, class, in our final answer, okay, so we have here x squared. What's the coefficient for x squared? It's 1. What's the coefficient of our 3x? Is 3. What's the coefficient of, yeah, we have here the constant negative 1. Okay, so basically we just have to um put uh, these variables beside the coefficients. Okay, another, we have x to the power of 4 minus 4x squared plus 6 divided by x minus 4. And again, class, in this case, the divisor is in the form of x minus k, or where k here is equal to 4. Okay, and the variable x has an exponent of 1, so that means to say we can apply the synthetic division. Okay, but first, we need to equate the divisor x minus 4 to 0. Okay, and that will give us x minus 4 equals 0. So you do, how do you call this one? Addition property, right? Addition property. So, or you can also transpose the negative 4 to the other side. So that's going to be x equals positive 4. So where do you put the 4? Here. There. Okay. And then, right after that, you have to list all the coefficients that you will see in the numerator or in the dividend. Okay, but do not forget to fill in the missing terms with zeros. Okay, just fill in with zeros. Okay, so for x to the power of 4, our coefficient is 1. Okay, but what comes after x to the power of 4? Right? It should be x to the power of 3. But since it's not there, so we have to fill it with 0. Okay? And then after x to the power of 3, it's going to be negative 4x squared, no? Or a term with an exponent of 2. So it's there. So we just have to bring down the coefficient, copy the coefficient, and it's negative 4. What's after negative 4x squared? It must be a term with an exponent of 1, but it's not there. So again, we have to add another 0. And then for the last number, we have the constant 6. Okay, so then we're ready to do mama. Okay, mama actually stands for multiply, add, multiply, add, multiply, add. So it depends as to how many numbers do you have there on top. Okay, so we bring down the first coefficient, which is 1. All right, we bring it down and we multiply it with 4 on the side. So 1 times 4 is 4. And then we add 0 plus 4. Then that's going to be 4. And multiply again. Remember, mama, 4 times 4 is 16. And then we add negative 4 plus 16. Then that is positive 12. 12 times 4, so that's 48. 0 plus 48, that's 48. 48 times 4, that is 192. 192 plus 6, that is 198. And again, notice that you have here 198 as our last number and not 0. So that means to say this particular problem has a remainder, and that is 198. Okay, so now we proceed with writing, no? Writing our quotient for this problem. So again, in the divisor, in the dividend, since the highest exponent is x to the power of 4, we subtract 4 with 1. So 4 minus 1, and that's 3, right? So that means to say, for our quotient, the highest exponent must be 3. Okay, so we write here x to the power of 3, then we have x to the power of 2, then we have x, and then we have the positive 48. Okay, so we write it beside, no? The coefficients are already arranged. There's that's why this method is way simpler, because we don't have to arrange, no? So we just have to write the variables with corresponding exponents to um beside these numbers. So we have 1 x to the power of 3 plus 4x squared plus 12x plus 48. And remember, how do we write the remainder? So that's plus 198 divided by the divisor x minus 4. Okay, easy, right? Another problem where we factor the polynomial completely given one of its factors. So you have here 4x cubed plus 8x squared minus 25x minus 50. So remember, we have to equate the divisor, which is x plus 2 with what? With 0. So x plus 2 equals 0. So that's going to be negative 2. Okay, so we put the negative 2 on the side, and then we write all the coefficients of the dividend. So we have 4, we have 8, we have negative 25, and negative 50. Then we bring down 4, no, which is the first coefficient. Then we do mama. Multiply, and add. So 4 times negative 2, that is negative 8. So we put it below the second number. And then add 8 plus negative 8, that's 0. So 0 times negative 2, that's 0, of course. Negative 25 plus 0, that's negative 25. And then negative 25 times 2, that's positive 50. Negative 50 plus 50, that is 0. So that means to say, our last number here is 0. Not positive number, not negative number. So that means to say, for this problem, we don't have a remainder. Okay, we don't have a remainder. Okay, so how do we write our quotient for this problem? So remember class that in the dividend, the highest exponent is to the power of 3. You subtract it with 1, 3 minus 1 is 2. Okay, so that means to say, in the quotient, the highest exponent must be 2. So you have 4x squared plus 0x minus 25. How do we write our final answer? So we have 4x squared minus 25. Why does it look like that? Go back to the problem. It says, let's try a problem where we factor the polynomial completely given one of its factors. So basically, class, if you multiply the x plus 2 with 4x squared minus 25, you will get 4x cubed plus 8x squared minus 25x minus 50. Okay, so as easy as that. So I hope you have learned synthetic division. Um, Thank you so much for watching this video. If this is helpful, please don't forget to give it a like. Thank you and see you in my next video.